Okay, so what we're going to be talking about today are special right triangles. All right, so let's take a look at the do now. So I have this right triangle, and it says to find x. So since it is a right triangle, and I have two sides of the right triangle, and I'm looking for the third side, we could use the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared is equal to c squared. So remember, c is your hypotenuse, and the hypotenuse is always opposite the right angle. So therefore, your a and your b are your legs. It doesn't matter which one you make a and which one you make b, because addition is commutative. So we have x squared plus the square root of 3 squared is equal to 10 squared. So x squared plus radical 3, or the square root of 3 squared, is the square root of 9, equals 100. So x squared plus 3 is equal to 100 minus 3. X squared equals 97. Take the square root of both sides. We get x is equal to the square root of 97. Okay, so we will use this later. Let's take a look at the first given down here. And we're talking about equilateral triangle ABC. Okay, so this equilateral triangle ABC has AB is equal to 1. Now, since it is equilateral, that means all the sides are the same. So if AB is 1, that means AC is 1, and BC is equal to 1 also. It also says that altitude CD is drawn. So remember altitude. Hopefully you remember the altitude from geometry. That means they form perpendicular lines, right angles. So I'm going to draw in CD. So this is D. Remember, altitude forms right angles. All right, now, since this is an equilateral triangle and I am drawing in the altitude, it does something special to isosceles triangles and equilateral triangles. The altitude, not only in an equilateral triangle, creates right angles, but it also bisects AB. So bisects means cut in half, so that means AD is equal to BD. So if AB, if this is equal to 1, and it's getting cut in half because of the bisector, that means each piece is equal to actually a half. So this is 1/2 and this is 1/2 here. Now also, since you have an altitude in an equilateral triangle, not only does it bisect the base, it is also an angle bisector, so it bisects angle C. So therefore, this angle here is equal to this angle there. So now in an equilateral triangle, all the angles are equal to 60 degrees. So if it's an angle bisector, that means this angle is 30 and this angle is 30. So what we're going to look at is just one piece of this equilateral triangle. I'm going to look at one of the right triangles. So if I just look at one of the right triangles, and I just look at this one, let's say, doesn't matter which one we could look at. We could look at the right one or the left one. So this is called a 30, 60, 90 right triangle. So inside the star, you would want to write that. So inside the star, write 30, 60. You should be able to fit it. I'm not going to be able to fit it on here. 90 right triangle. All right, so now I'm going to redraw my right triangle over here. All right, so this is my right angle, D. I have B and C. This is 60, 30 degrees. This is 1. This is a half. Now, I have a piece of the right triangle missing. And what I'm missing is the altitude, CD. So what I'm going to use is the Pythagorean theorem to find that missing piece. So remember, the Pythagorean theorem is a squared plus b squared equals c squared. C is the hypotenuse, and in this case, the hypotenuse is 1. So I have a squared plus 1/2 squared is equal to 1 squared. X squared plus 1/2 squared is 1/4 is equal to 1. Minus 1/4 from both sides. So you can use your calculator. So 1 minus 1/4 though is 3/4. Take the square root of both sides. I get x is equal to, just going to bring it over here, the square root of 3 over the square root of 4, which is the square root of 3 over 2. So therefore, this side right here is now equal to the square root of 3 over 2. Let me get rid of that now. Okay, now let's talk about sine, cosine, and tangent of this right triangle. So let's take a look at our 60-degree angle here. So I'm looking down here. I want sine of 60 degrees. I want to know what that's equal to. So remember, sine is equal to opposite over hypotenuse. So which side is opposite? That's radical 3 over 2, and the hypotenuse is equal to 1. So I have hypotenuse, opposite, and this is the adjacent side. So I have the square root of 3 over 2 over 1, which is just the square root of 3 over 2. So that's sine of 60 degrees. Cosine is the adjacent over the hypotenuse. So that's 1/2 over 1, which is equal to 1/2. Tan is opposite over the adjacent. So that's the square root of 3 over 2 over 1/2. So I'm dividing fractions. I have a fraction divided by a fraction. I'm going to do same change flip. So it's the square root of 3 over 2 times, flip the fraction, 2 over 1. The 2 is reduced to 1 and 1, so I'm left with just the square root of 3. All right, so now we're going to do sine, cosine, and tangent for 30 degrees. So everything will change a little bit. So the hypotenuse will stay the same. So I'm actually looking over here now at 30 degrees. Hypotenuse will stay the same, opposite the right angle. Now my opposite 30 is 1/2, and my adjacent is now the square root of 3 over 2. All right, so let's start with sine of 30 degrees. Sine is opposite over hypotenuse. That's 1/2 over 1, which is equal to 1/2. Cosine is the adjacent over the hypotenuse. That's the square root of 3 over 2 over 1, which is the square root of 3 over 2. Tangent is opposite, which is 1/2, over the adjacent, which is radical 3 over 2. So that's 1/2 times 2 over the square root of 3. So the 2 is reduced to 1 and 1. So I have 1 over the square root of 3. So hopefully from geometry you remember to rationalize the denominator. So we multiply the top and bottom by the square root of 3. So we get the square root of 3 over, that's the square root of 3 over 3. Okay, so let's flip the worksheet over. We'll refer back to this in a minute when we fill in our table that's on the other side, but we have to do one other triangle. Okay, so let's take a look at the given triangle. It's isosceles right triangle ABC. So isosceles means it has two congruent sides. So in a right triangle, the two congruent sides have to be the legs. So that means AB is equal to BC. And my hypotenuse AC is equal to 1. So what I want to do is be able to find these two sides here. Now, since it is an isosceles triangle, and this angle here is a right angle, these two sides are equal. That means angle A and angle C have to be equal to each other. So have two congruent sides has to have two congruent angles. So if this is 90, 180 minus 90 is 90. Divide that by 2 is 45. So therefore, each one of these angles is 45 degrees. So this is called, so inside the star you want to write, it's a 45, 45, 90 right triangle. So make yours nice and neat inside that star. All right, so we're missing the side, and they're both x because they're both equal to each other. I'm going to use the Pythagorean theorem to find the missing sides. So that's a squared plus b squared is equal to c squared. All right, remember c is the hypotenuse, so I have x squared plus x squared is equal to 1 squared. X squared plus x squared is 2x squared is equal to 1. Divide by 2. X squared is equal to 1/2. Take the square root of both sides. I get x is equal to the square root of 1 over the square root of 2, which is 1 over the square root of 2. Rationalize the denominator. Multiply top and bottom by the square root of 2. I get the square root of 2 over 2. So I have those sides here. This side is the square root of 2 over 2, and this side is also the square root of 2 over 2. All right, so now what I want to do is sine, cosine, and tangent of 45. Now notice I only wrote it once because they're going to be the same. So let's start with sine of 45 degrees. It does not matter which angle you look at because they're both the same. So I'll look at here. One is the hypotenuse. Opposite 45 would be here. And adjacent would be this side. So sine is opposite over the hypotenuse, which is the square root of 3 over, square root of 2. Square root of 2 over 1, which is the square root of 2 over 2. Cosine of 45, that's adjacent over hypotenuse. So that's the square root of 2 over 1, which is the square root of 2 over 2. And tan 45, that's opposite over the adjacent. So that's the square root of 2 over the square root of 2 over 2, which is equal to 1 because anything divided by itself is equal to 1. All right, so now what we're going to do is fill in this table here. And so notice that in this table I have sine, cosine, and tangent, and I have some angle measures. Some of them are familiar because we did 0, 90, 180, 270, 360. We've done those before. We've made a table with them. We're just adding to that table. And now I'm going to add 30, 45, and 60. So I'm going to fill in this quadrant. And this will help us take care of the rest of the quadrants because the rest of the quadrants, remember, are the same thing, but just whether or not it's positive or negative. So to do sine of 0, remember you're supposed to know that unit circle, right? So the unit circle here looks like this. This here, remember we're to the right one, that is 1, 0. Up 1 is 0, 1. This one is negative 1, 0. And this is 0, negative 1. So sine of 0 degrees, remember sine is the y value, cosine is the x value, so this is y, this is x, this is sine over cosine, tangent. So sine of 0 degrees is 0. Cosine is 1. Tangent is sine over cosine, that's 0 over 1, which is equal to 0. Now, of course, if you forget that, you could just plug that in your calculator. You could plug in your calculator sine of 0 degrees, you'll get 0. All right, so now let's do sine of 30. So you're going to have to look back on the other side of this paper and tell me what is the sine of 30 degrees equal to. So the sine of 30 degrees is equal to 1/2. Now what I want you to do is plug it into your calculator. Plug in sine of 30 degrees. And what do you get? You get 0.5, which is equal to 1/2. All right, so look on your paper on the other side. Cosine of 30 degrees. That's equal to the square root of 3 over 2. Now what I want you to do is plug it in your calculator, cosine of 30 degrees. So cosine of 30 degrees, you get on your calculator, 0.8660. All right, so you're going to have to know that. So now look on the other side. Tan of 30 is the square root of 3 over 3. And I want you to plug that into your calculator, tan 30, and you get 0.5773, sorry. Okay, so now let's go to sine 45 degrees. That's actually on this page, this side right here. So sine of 45 degrees is the square root of 2 over 2. I want you to plug that into your calculator, sine 45. And sine of 45 is 0.7071. So you should be writing these decimals next to your fractions. Cosine of 45 degrees, we're back over here. That's square root of 2 over 2. It's the same thing, square root of 2 over 2. Plug that in your calculator, cosine 45, you get 0.7071. And tan 45, which is right here, is equal to 1. All right, so now let's go to 60 degrees. So sine of 60 degrees, look on the other side. Sine of 60 degrees is the square root of 3 over 2. Plug it in your calculator, sine 60, it's 0.8660. Cosine 60 degrees, look on the other side, is 1/2, which is 0.5 when you plug that in. So plug in cosine 60, you'll get 0.5. Tan 60, look on the other side. is the square root of 3. Plug tan 60 into the calculator, and you get 1.732. All right, now I'm up to sine, cosine, and tangent of 90 degrees. That's back to our unit circle because we're on the axes. You could plug it into your calculator if you needed to. So sine of 90 degrees is 1. Cosine of 90 degrees is 0. Tangent of 90 degrees, remember, that's sine over cosine. That's 0 over 1, which is undefined. So if you plug sine of 90 into your calculator, you will get 1. If you plug cosine of 90 in your calculator, you'll get 0. Now, what you need to look at is plug in tangent of 90 degrees into your calculator. And when you plug tangent of 90 degrees in your calculator, you get this domain error. That's because it's undefined. Okay, so you have to know that. A domain error is undefined. All right, so let's go to sine of 180 degrees is 0. Cosine is -1. And tangent is sine over cosine, which is equal to 0. All right, now we're down here on the unit circle. Sine of 270 is -1. Cosine of 270 is 0. And tangent is undefined. And we're back right around at 0 degrees for 360. So that would be 0, 1, and 0. All right, so what do you have to know from here? You have to know, super important, so you're going to have to make flashcards, whatever you need to do. You have to know those decimal conversions. You are going to have to know, and this one you should already know, it's 0.5 is a half. So there's only a couple you have to know. You have to know that 0.8660, when you see that is the square root of 3 over 2. You have to know that when you see 0.7071, that is the square root of 2 over 2. When you see 1.732, that is the square root of 3. And when you see 0.5773, that is the square root of 3 over 3. So I have it all for you down here at the bottom of the sheet. Okay, so let me just move all the red stuff up. And down here you can see at the bottom of the sheet are all your decimal values. Okay, so make sure you know them. Make flashcards, whatever you have to do, but you have to know them. Okay, so that is it, and I hope you guys have a good night. I'll see you tomorrow in class.